Okay, so let's start. Let's start kinematics. Okay, so over here, a particle moves in a straight line from a point O such that t seconds after leaving O, its velocity v is given by blah blah blah. So find the initial acceleration of the particle. Okay, so I will not cover much on the basic of how to differentiate or how to integrate. So I've covered those in previous TikTok live, and I also did one TikTok live basically on the five rules of differentiation. So you can always go to my go to my YouTube channel, go and search for the differentiation 5 rules. If your differentiation sucks, okay, it's just like saying that your basic is not good, and then after that, when you're doing application of differentiation or integration, you cannot do it one. So you must always go and master the basic, which is the 5 rules of differentiation, which I did it very detailed inside my YouTube channel. Go and visit it and make sure you master your differentiation. Okay, so over here, my V is here. So for the kinematics, so you know that you have the S represent the displacement. Okay, you have the V represent the velocity, A represent the acceleration. So SVA. Okay, so you need to know that this direction, when displacement go to velocity, velocity go to acceleration, this is using differentiation. So this direction is differentiation, differentiate. So when you go, let's say this direction, okay, when you are given acceleration, you want to find velocity, you will have to integrate. You are given V, you want to find the S, you have to integrate the V. So this side is to integrate. So basically you need to know this, okay, and make sure that whenever you integrate, there's always a plus C. That's a very, very, very critical part. So later part we will cover definitely. So this question, I'm given velocity. So they asked me to find acceleration. So you look at this, I'm given V, I want to go A. It means that to find my A, I need to differentiate my velocity. So in other words, we're supposed to differentiate this. So actually differentiate this, in this case, I can actually just apply chain rule. So over here, I'm going to bring the 2 down. So it becomes 10 4t minus 1. Power minus 1 means 2 minus 1, so it's 1. So I don't have to write 1. Multiply by differentiate inside. And inside is a 4, so I have to multiply by a 4. And then this minus 125, when you differentiate a constant, it disappears, so no more. So I only left with this. So it becomes 4t minus 1. You can actually just rainbow this. It's 160t minus 40. So this is my acceleration, the expression for acceleration. Then they ask for initial. Initial means the start. Okay, the start means t equals to 0. So this means is t equals to 0. So all you need to do is sub t equals to 0 into your acceleration. So sub t equals to 0. So my A is 1600 minus 40. So I get negative 40 meter per second squared. So acceleration, the unit will be this. So this is the first part. Okay, part 2. Next, they ask, find the value of t at which the particle is instantaneous at rest. Okay, every time you see this, straight away link to, oh, I want to find velocity equals to 0. You want to solve the equation for v equals to 0, find the corresponding t. So in this case, my v is here. So I say that my 4t minus 1 square minus 125 equals to 0. So for some students, they may think, straight away, okay, I'm going to solve this as a quadratic equation. But for this situation, actually I can I don't have to expand. See how I solve this. So 4t minus 1 square equals to 125. And this is times 5. So bring over 4t minus 1 square equals to 125 divided by 5. So it's 25. And just nice, 25 is a perfect square, whereby I can square root easily. So just take note that when you square root, you have plus and minus. So I have 4t minus 1 equals to 5, or 4t minus 1 is equals to negative 5. So I have 4t equals to 5 plus 1, so it's 6. So t equals to 6 divided by 4, t equals to 1.5. Over here, my 4t is equals to minus 4, my t is equals to negative 1. And because time cannot be negative, so this one you will reject. So in this case, you will know that, oh, okay, So v equals to 0 are trying to tell you your particle actually turn direction. So if there's only one t, means that it's going to change direction one time. So in this question, they only ask you to find the t. So this is the answer for part 2. So this part is just warm up. It's simply just differentiation and sub accordingly. So over this question, things you need to take note is what you learn is initial means t equals to 0. Second thing is when they say at rest means v equals to 0. Understand? Okay, so this is for question number 1. Let's move on to question number 2. No, this is not A level, this is O level. AMath Express, AMath Express Sec 4, Sec 4 Express O level. Okay, so now let's take a look at question number 2. Okay, anytime when you have question, you can always ask, but please ask properly in the chat. That means ask me like, oh, okay, Che, how you get the, how do you solve t equals to blah 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 blah. You ask properly, I will answer you. Don't tell I don't understand what is your, I will not know what is your how also. So feel free to ask and pause and ask me question if you need to. Okay, so the best way to learn is now you listen. Okay, even if you understand 50-60% is better than 0%. And then after that, write whatever notes that you whatever notes that I say, and then you just follow first. If you even understand 50-60% is fine. Okay, and then after that, you just watch the replay on the YouTube channel whereby we will upload tomorrow. Okay, then after that, you will listen to it and then you try it yourself again. Then in that case, 50-60% will become 100%. This is how you learn things. So never give up when you start to learn something new. Hey, I only understand 50-60%. Hey, it's better than nothing. It's normal when you're learning new things. Okay. Sure, I fail my math and I don't understand the question. I don't know what you mean by understand which question. Are you talking about this question or you're talking about your school AMath, your school paper? Okay, that one I cannot help you lah. Okay, I can help you if you can go to my YouTube channel, go and watch whatever topics that you are weak at, and then go and learn from there. Yeah, if not, you can sign up for my class, my tuition class. Mine is 1-to-1. Not exactly 1-to-1. Mine is a group tuition, but my attention is 1-to-1. That means I tailor the topics and lesson plans according to your weak topics. That's how I teach. Okay? Okay, next question 2. A particle moves in a straight line so that t seconds after leaving a fixed point O, its velocity is blah blah blah. Okay? Find the acceleration of the particle when it comes to instantaneous at rest. So first, they are showing this, so I know I want to do v equals to 0. Are you a qualified school-based MOE teacher? No, I'm a full-time tutor. I teach for the past 11 years. So I'm not in the school. Who block? Who block? Much do you block? Are you the one who block? Why you go and block? Can you go to the block list and please go and unblock the Justin 123? Okay. Wait, give me a moment. Okay, later you go to the block list and please help me to unblock the person. It's not necessary to block that one. Okay. Anyway, let's move on. Let's move on. Okay, so over here they say that find the acceleration when v equals to 0. So you have two things to do. First, you need to sub v equals to 0 to find out what is the time first. And then after that, you need to find the acceleration expression by differentiating the v. So I'm going to sub v equals to 0 first. Over here, so let's sub v equals to 0. So over here, it will be 24t, t minus 1 minus 48 equals to 0. So this, I'm going to rainbow this. So I will have 24t squared minus 24t minus 48 equals to 0. This is an quadratic equation, and I can reduce it to smaller equation first, because all of them can divide by 24. So I'm going to divide by 24. So I will have t squared minus t minus 2 equals to 0. So then after that, factorize this. So I will have t minus 2, t plus 1 equals to 0. So we have t equals to 2 or t equals to negative 1. And remember I said t negative means you cannot reject, you must reject this one. So reject this. So I only have t equals to 2. So then next is, I want to sub t equals to 2 into my a. But at the moment now, I do not have my a yet. So I need to differentiate my v. So I need to find my a, differentiate my v with respect to t. So over here, let's see. Okay, I'm going to rainbow this out, which is v is equals to, actually I will have it here. So that means I am going to differentiate with respect to t, 24t squared minus 24t minus 48. So we're going to differentiate this. So bring down the 2, you will give me 48t and minus 24. So this is my a expression. I want to find the acceleration, simply just sub in the t equals to 2 into here. So sub t equals to 2. So my a is equals to 48 minus 24. And that will give us 72 meter per second squared. And that will be the answer for part 1. Very straightforward. Okay, now let's move on to part 2. They say explain why the velocity of the particle is never less than negative 54. Okay. So what you need to do is, okay, let's analyze our velocity expression. V is equals to 24t, t minus 1 minus 48. A lot of times they ask to prove this kind of thing, is you have to make use of the completing the square. So what we're going to do is, I'm going to rainbow this out first. So we will have 24 24t squared minus 24t minus 48. So I want to do completing the square. Completing the square can only be done at 1t squared. So I'm going to take out common factor 24. Take note, take out common 24 and not divide by 24, because this is not an equation, it is an expression. So take out 24, I have t squared minus t minus 2. So we're going to do completing the square inside this round bracket. So we will put 24, put a square bracket, t minus, look at the coefficient in front of the t, which is 1. Okay, so here is 1 over 2. Close it, square, minus backside square. And what is this backside? The backside is the half. Don't bother about this minus. This minus simply is because this is minus. So my backside is just a half. So it's minus half square. And don't forget to bring down your negative 2. So let's simplify the whatever is inside the square bracket. So we have 24 t minus half square. This is minus 9 over 4. So take note, I am still inside my square bracket. So common mistake is students, oh okay, forget to rainbow this. Will it be easier if you keep the constant outside? Yes, that's why my 24 is outside. See, I take out the constant and put it outside. So I focus on doing completing the square for the t square minus t minus 2. Until I complete already, then I do the last step by rainbow the constant. So in the end, I have 24 t minus half square minus 54. So you see, now I have changed my v into this form. It is still the same, it's just that I change it to become the completing square form. So, as in the 48. For me, it's usually I do it together with inside because I want to combine it with this one. My 48, I don't like to put it outside because I want to combine it with this minus backside square. Do you see that? Okay, so after this, okay, look at this. This is a happy face because it's a is more than 0. This is a is more than 0, so it's a happy face. When we put it into this form, we can easily find out what is the turning point. So with this, I know that my turning point is half comma negative 54. And what does that mean? This is minimum point. Minimum point means that my minimum Therefore, my minimum V value is equals to negative 54. You see this, minimum value is already negative 54. Will it go even lesser than negative 54? No, because that's already your minimum. You understand? Your graph actually moves upwards. So the lowest value is already negative 54. That is why my velocity will never be less than minus 54. This part? No, the minus should not be inside the bracket. Okay, let me explain a little bit about the completing the square. So actually what we are doing is, okay, let me show this one. So when my t square minus t minus 2, when we want to change into the completing square form, this part, when I change it to t minus half square, okay, you ask yourself, if I'm going to rainbow this out, okay, I put it outside here, it is actually t square minus t plus 1/4. Right? If I'm going to rainbow this, it's actually this. But you see, I'm actually wanting these two terms. So when I do into the completing square form, I actually have an extra 1/4 here. Agree or not? So I'm always trying to minus away the backside or minus away the extra term. That is why the behind it is always minus the half square. This is forever minus, because what I'm trying to do is I want to minus away this extra term, because I want to keep it as t squared minus t. Okay, and then of course not forgetting your minus 2 must just put it behind. So this is how completing square works. You understand? This is how completing square works. Okay, so in other words, from here to here, this is the same value as this expression. Yeah, okay, so you need to know that it's always minus backside square. So I don't need the minus inside. I don't need the minus. Although you square it, it still become positive. But a lot of times, my students, when their paper is back, when I see how the teacher mark, they will actually penalize if you put a minus inside. So don't put a minus inside the bracket. Okay, so over here, I already say that, okay, I already proved that it is, my minimum is negative 54. So I will say, therefore, the velocity is never less than negative 54 meter per second shown. Okay, so this is for question part 2. Question part 2. Okay, let's move on to question number 3. Okay, this question number 3 is a good one. Okay, later I will show you why. Okay, a particle move in a straight line so that after t seconds its distance s meter from a fixed point is given by blah blah blah. Okay, this is exponential. This is exponential e. First, find the distance of the particle from O when t is equals to ln 2. And by comparing with the instant when the particle first moved off, determine if the particle is moving towards or away from O. So, sounds very cheap. Okay, first thing is I need to find out where is my particle at the initial stage, which is t equals to 0. So the first thing is I'm going to sub in t equals to 0 into my s first. So my s will be e to the power of 0 minus 5 over 2e0 minus 7. Okay, so I will get 1 minus 5 over 2 minus 7, and I get negative 8.5 meter. You see this? My displacement is negative. So when students see s equals to negative, they panic. Got wrong or not? Yes, you should panic a little bit, so that you will just suck in and check whether you can make any mistake. But when you confirm that your s is negative, okay, you are not wrong. It simply means that the particle at the start, it is behind the starting point. You understand? Because the difference between displacements and distance is, displacement is where the object is from a reference point. So I always draw diagram. So over here, this is the reference point. this is the reference point O. When my t equals to 0, s equals to negative 8.5, it means that your particle is over here when t equals to 0, s is equals to negative 8.5. That means it is behind the reference point. At the start, it is here. 80% of the time, your object always starts from the O, whereby t equals to 0, s equals to 0. But in this case, t equals to 0, s is equals to negative 8.5. This negative represents that I'm behind my reference point 8.5 meter. Understand? So this is my starting. Thank you. Okay. This math is what chapter? This is AMath. This is AMath Set 4 Kinematics. Is the last topic. Not exactly last topic. Sometimes, most of the time, school teacher will go through proof in geometry at the last one. So this could be the second last. Answer is 42. Answer what? 42. Okay. So over here, minus 8.5. Next is that I need to find the distance of the particle when t equals to ln 2. So same thing, I'm going to sub in t equals to ln 2 into s. So my s is equals to e to the power of ln 2 minus 5 over 2 e ln 2 minus 7. Well, I don't know, like Form 4, I don't know what is your chapter. Everyone textbook also different. Somewhere this I'm doing Singapore math. I believe you all also have the same topic, okay, but I don't know what chapter is it. So you need to know which chapter it belongs to your own textbook. Even in Singapore math, use different textbook. It could be this person, this chapter, this person, this chapter. I'm using OBS. English for Sri Lanka, I'm using OBS. Okay, so after I sub in e to the power of ln 2, I will get 2 minus 5 over 4 minus 7. Differentiation I went through in the past. You can go to my YouTube channel and go and search differentiation topic and then see what videos that come up. And my s will be negative 6.25. So this tells me what? Okay, see here. When t equals to 0, I am 8.5 behind my reference point. When t equals to ln 2, my s is negative 6.25. So it means that I'm still behind. Okay, I'm still behind my O. Okay, so t equals to ln 2. English for Sri Lanka, you can go to my TikTok bio, click on the link, the second last button, go to my YouTube channel. Okay, so t equals to ln 2, my s is equals to, I did before, you go and search Brian. Okay, t equals to ln 2, my s is equals to negative 6.25. So it means that, t equals to 0, I'm 8.5 behind. And then after that, after some second, which is ln 2 second, I move forward, move towards O. And I'm now nearer to O, but I'm still behind. I'm 6.25 behind my reference point. You understand? So you see this question, they say, by comparing with the instant when the particle first moved off, determine if the particle is moving towards O or away from O. So you can see that it's actually going towards O. So the answer is, therefore, it is towards O. Can everyone understand this part? Okay, that is why I always ask my students to always draw out the diagram. You need to know where you are, or in other words, you need to know where is the particle. Where is the particle? Okay, let's move on. Okay, they say find the value of t when the blah blah blah. March, can you take note that this one spelled wrongly? This is velocity. The V is supposed to C. Okay, so find the value of t when the velocity is blah blah blah. So I'm given my s. So in order to find V, I need to differentiate the s. So V will be ds dt. So let's differentiate the exponential. So I'm going to change this to this form. See here, ET will remain. I'm going to change the index form. So it becomes 5 over 2 e to the power of minus t. This ET I bring up, it becomes e to the power of minus t, then minus 7. Because in this form, it's easier to differentiate. So differentiate exponential is keep the same, multiply by differentiate the power. In this case, differentiate t is just 1. So it's multiplied by 1. Okay, now differentiate this. The constant will just remain the same first. No need to do anything to the constant. So then after that, you differentiate this is keep the same. Differentiate the power give me negative 1. So multiply by negative 1. And differentiate minus 7 just disappear. Sure, you can use those erasable pen. No need lah. Why I need to use the erasable pen? Oh, because correction tape ma. Oh no lah. I don't like to use the erasable pen because after that the color will fade after some time. But thanks for the recommendation. Okay, so to simplify, it becomes e to the power of t minus 5 over 2. Take note, minus minus, this one become plus. So the 2 is there bottom, so now it becomes this. So this is my velocity expression. So this is my, shouldn't it be integrated to obtain velocity? No, SVA. SVA, So you need to differentiate S to get the V. Remember just now I teach, see over here, SVA, to get the V, I'm given S, you need to differentiate, not integrate. So this is my V. Now I need to find V equals to 5.5. So I just need to sub V equals to 5.5. So I have ET plus 5 over 2 ET is equals to 5.5. Okay, it looks a bit difficult to solve it, right? Differentiation is not confusing. Go to my YouTube channel and search for the differentiation 5 roots. Go and master your differentiation. Okay, so now this question looks very difficult to solve. Okay, the trick is whenever you see something whereby your power got the unknown, and you see duplicate. In this case, I see e to the power of t, I see e to the power of t. So I'm going to make use of substitution. So I'm going to let u equals to e to the power of t. So temporarily, I'm going to change my e to the power of t into u first. So now it becomes u plus 5 over 2u equals to 5.5. So I need to times 2u throughout. So multiply by 2u throughout. I get 2u squared plus 5 equals to 11u. Shift everything to the left hand side. So 2u squared minus 11u plus 5 equals to 0. Factorize this. So I get u minus 5. 2u minus 1 equals to 0. And you will solve u is equals to 5 or u equals to half. Don't stop there. Remember, I only temporarily let the e to the power of t be u. And I solve my u first. I need to bring back my e to the power of t. So continue over here. So my e to the power of t is equals to 5 or e to the power of t is equals to half. Then I solve this. Then I solve this. How to know again where to factorize? What by where to factorize? You're using cross method to factorize this. Okay, so now to solve this, I need to ln both sides. So I'm going to ln both sides. So it becomes ln ET is equals to ln 5. Power law tells me that I need to bring the t down. So it becomes t ln e equals to ln 5. And you must know that ln e is 1. So my t is equals to ln 5. Put it as 3SF, so it's 1.6094, which is round off 1.61 second. This is 3SF. This one, I'm going to ln both sides also, okay, I have ln e t is equals to ln half. T is equals to negative 0.6931. And again, t cannot be negative, so over here you can just reject this. So therefore, they say find the value of t when velocity is this. I done. This one is the answer. This is the answer. So in this question, you need to know how to differentiate exponential. Okay, exponential. So I have already said that, okay, differentiate exponential is keep the same and always multiply by differentiate the power. Okay, see, keep the same. Differentiate the power is negative 1, that's why I done negative 1. So this is how you differentiate exponential. So that is for question 3 part 2. Okay, so let's move on to question number 4. Okay, over here we will start to do integration already, because now I'm given v. Later I'm going to find s. If I want to find s, I will have to integrate the v. Okay, so let's read the question together. Okay, so for those who are new here, just let me just share. You need to go to my bio, click on my bio link, and then go to the last button. You will join my TikTok. You will join my Telegram channel. So that's where you can get the PDF worksheet of these particular questions, topic that I'm doing now. Tomorrow, then we will upload the solution. Solution means the live I'm doing the working, right? So we will also upload that. So we will have, like, when you see the PDF now, if you go now, you will see a blank one. That means purely no solution. It's just a question. Tomorrow we will upload another version whereby the front is the empty one, but the behind we will attach the solution, and we will also send you the link to the YouTube channel whereby you can see the replay of today's lessons. Okay? Yes, and also don't forget to follow me so that next time when I have, I'm going to do O Level revision in September and October. August, actually, I'm already starting to do revision. But for August, I'm doing topical revision. September, then I start to do papers to revise. So remember to follow me. Okay, so that you will get a notification when I'm going to do live. A particle moves in a straight line so that... Why is there a face in the paper? That's watermark. Watermark. Thank you. And that's my face, by the way. Just cartoon. Okay, a particle moves in a straight line so that its velocity is given... Okay, so that its velocity is given by v is equals to blah blah blah. So where t is the time in seconds after leaving a fixed point O, thanks. Okay, its displacement from O is 9 meters when it is at instantaneous at rest. So again, when you see this, it say that v is equals to 0. Okay, v equals to 0. So now they are trying to say that my s is equals to 9 when t equals to, I still don't know yet, because I need to find out my v equals to 0, what is the t first. Then I can put it here. So over here, part 1, you see, they said find the value of t when it is at rest. So I need to let v equals to 0. So we are supposed to sub v equals to 0. So take this, 2 minus 18 over t plus 2 square is equals to 0. So we will have 18 over t plus 2 square is equals to 2 over 1. Cross multiply, so I have 2t plus 2 square equals to 18. Again, this situation I don't expand, because I can see that 18 divided by 2 is 9, and 9 give me a perfect square. When you give me a perfect square, that means that I can square root later. So I don't need to go and expand and do the usual quadratic formula. So it means t plus 2 is equals to 18 over 2, and t plus 2 is equals to square root 9 with the plus minus. That's where I get t plus 2 equals to 3, or t plus 2 equals to negative 3. So t equals to 1 and t equals to negative 5. Again, t negative 5 not applicable, so you reject this. So it means that when v equals to 0, t is equals to 1. And over here, I can plug it back here already. They say displacement from O is 9 when it is at instantaneous rest. Means S equals to 9 when T is equals to 1. This 1 is because I do this working over here. Okay, so now they ask, find the distance traveled during the first 4 seconds. Every time they ask you to solve for distance travel, you must always find out whether your object turn direction, change direction. In this case, I already do the V equals to 0. It means I know that my particle will change direction at T is equals to 1. So sometimes the question never asks you to do V equals to 0, but you must automatically must do V equals to 0 to find out the turning point. So in this case, I'm going to find my S first. My S, I need to integrate my V with respect to T. See here. So let's do. I'm going to integrate the 2 minus. Okay, I'm going to change this form because this form is not easy to integrate. So it will become 2 minus 18 bracket T plus 2 to the power of minus 2. So all I did was I just bring the T plus 2 square, bring it up, so it become negative 2. So now with this, it's easy to integrate. So 18 T plus 2 negative 2. So now we are ready to integrate. Integrate 2 is just 2T. See here, see how I integrate this. Minus 18, keep it there. Now power plus 1. So it is T plus 2 minus 1 over the new power and differentiate the inside, which is 1. See how I integrate? Power plus 1, so it's T plus 2 negative 1. Over, because you're doing integration, so it's over, put the new power at the denominator, and don't forget to differentiate the inside. In this case, differentiate the inside is 1, so put it at the denominator. Okay, I always make it a habit, even though it is 1, I still put it. So it's just to remind myself I did what I have to do. And then after that, don't forget to put your plus C. So let's simplify this a little bit. So S will be equals to 2T plus 18 over T plus 2 plus C. So how to solve the C? Okay, usually, okay, the question will give you a set of values. That's the reason why they give you this information over here. When S is equals, when T equals to 1, S equals to 9. So I can sub this in to find out what is my V. You understand? But if they never give you this information, then by default it means that your particles start from the origin. It means that T equals to 0, S equals to 0. But for this case, it's not. For this case, we have this, so we will sub this in to find my C. So we will sub in T equals to 1 and S equals to 9 into here in order to find my C. So we have 9 equals to 2, 1 plus 18, 1 plus 2 plus C. 9 equals to 2 plus 6 plus C. So my C is equals to 9 minus 8. C is equals to 1. C is equals to 1. Once I have my C, now I can have my complete S. So my S will be equals to 2T plus 18 over T plus 2 plus 1. So this is your S expression. Okay, very, very critical to know what is your C. Cannot assume that C is always 0. It is not. It is not. So now I have my S. I need to find the distance traveled. So I'm going to draw the diagram. First, I need to know where is my particle at the initial stage. So I need to sub T equals to 0 into my S first. So I will have S equals to, so refer to this one, 2, 0. So 2, 0 plus 18, 0 plus 2 plus 1. So I have 10 meter. So in this situation, my particle did not start from the origin. So my diagram will look like that. I'm going to draw it above here. See, this is your reference point. When t equals to 0, my s is 10. It's not negative. If it's negative, it's behind the O, remember? Now it's positive. That means my particle will be here. So I'm going to mark out here and put here 10 meter. So that means starting my particle is here. Not here, here. So I can put here t equals to 0. This is where my particle is at the start. Okay, and remember just now we have a turning point. Okay, so I need to know what is my actually I don't need to find out already because I already have this. Remember, t equals to 1, s equals to 9. So it simply means that my particle over here, it will like that, here. It will turn at this part whereby t is equals to 1, s equals to 9. Starting, it is 10 meter from the O, and then after 1 second, it becomes 9 meter from the O. That means it got stand back, it moved backwards by 1 meter at t equals to 1. Then over here, they asked to find for first 4 seconds. So it means that I need to go and find out at t equals to 4, what is my s first. So now next is we're going to sub in t is equals to 4. So my s will be 2, 4 plus 18, 4 plus 2 plus 1. That will give us 8 plus 3 plus 1, which is 12 meter. So because here is 10, right? So 12 meter will be a little bit more lah. So here is 12 meter. Do you see that? So see here, starting my particle is 10 meter from this reference point. Then after that, it moved backwards. After 1 second, it's 9 meter from the O. And over here, it changed direction. So that's why it go into in front, move forward. And when at t equals to 4, it is 12 meter from this reference point O. Okay, so the O is the reference point. So you need to know that the S is 10 from the O. The S is 9 from the O. The S is 12 from the O. Understand? This is your reference point. Okay, so now we are ready to calculate the distance travel. So my total distance travel. So now let's take a look at my diagram. The first 1 second, it was here. Then it goes stand right. It goes backwards by 1 meter. So the first 1 second, it is 10 minus 9. It only moved 1 meter. It only moved 1 meter for the first 1 second. Then now from the T1 to T4, from 9, it go to 12. But take note, okay? Take note, it only moved 3, It only moved 3, because it was 9 meter away from O. After 3 seconds, when it go to T equals to 4, it becomes 12 away from the O. So actually, it only moved 3 meter. So it is plus 12 minus 9. Understand? You need to draw the diagram, then you can visualize better. So in the end, we know that it is 1 plus 3. So total distance travel is only 4 meter. Understand? So this is exactly how you find those kind of distance travel. Distance travel kind of a question. Okay? All good with this question now? So next time when you see this kind of distance travel, always find out the first thing, where does my particle change direction? Second, where is my particle at the start? So in this question, my particle is at the start at 10. Change direction at t equals to 1. Then I find the final one because they want 4 seconds. Then you draw the diagram. It's easier for you to visualize how much the particle has moved. Okay? Okay, so we are done with question number 4. No, 4 still got third part. Wait, Okay, this one also pretty tricky. They say at t equals to 7, the particle starts with a new velocity. Another velocity expression, which is this one. But it is at the same so-called same diagram. They are saying that from t0 to t7, the velocity is this one. Then when the t equals to 7 onwards, they change to another velocity. Velocity is, in other words, is speed. Speed is without direction. Velocity is speed with direction. So they are just trying to tell you from 0 to 7, this particle is moving at this speed. And then from t7 onwards, your particle change speed. That's all. Understand? So then they ask you, find the value of k. So in this question, first I need to find out what is my v when t equals to 7. OV, OV. So my OV was this one. So I will sub my t equals to 7 into my OV. So my OV is v is equals to 2 minus 18 over 7 plus 2 squared. And that gives me 16 over 9. This is my OV expression. What am I doing the wrong way? I don't understand what you mean by doing the wrong way. Can you explain? Which part is wrong? I'm open if I make mistake, but please tell me where I go wrong. If not, I just thought that you're going to just disturb me. Okay, so my V is this one. Okay, then because there's a transition, the velocity, it was this speed, means that now so-called at t equals to 0, because I'm changing a new velocity, so I will now sub t equals to 0 and v equals to 16 over 9. I'm going to, this is big capital V. This is big capital V equals to 16 over 9 to my big V. Just now was small v. Now it's big V. So now it becomes 16 over 9 equals to minus h 0 square minus 70 plus k. So in this case, my 16 over 9 equals to my k. And we are done. So therefore, k is actually equals to 16 over 9. So in other words, your new velocity expression is now minus h t square minus 7t plus 16 over 9. Okay, they never asked to form this one. This is for my own information, because later I'm going to use it. This part, they only asked me to solve my k. You understand? So you see the transition? Do you see the transition? Okay, I use the OV, find the velocity first. And then after that, it changed to another V, right? But when it, in reference to the new V, it is t equals to 0, because it is a new velocity. That's why I sub t equals to 0, V is equals to 16 over 9 into the new V to find the k. Okay, so once we have that, now they say given that the deceleration is 0.9. Okay, take note. Do you see that this is deceleration? This tells me that my acceleration is equals to minus 0.9. The deceleration represents negative. My acceleration, so is negative 0.9. So they tell you my acceleration is negative 0.9 when t equals to 8. Find the value of h. So I need to find my a. So SVA, to find my a expression, I need to differentiate my v. So this time round, I cannot use small a, right? Because small a just now we already used. But anyway, you want, you can use as a2. I can write it as a2 because just now previously we already have my acceleration. So A2 is, I need to differentiate my big V with respect to t. Okay? So this was my v, right? So how to differentiate this? Let me just rainbow this first. So it will be minus ht squared plus 7ht plus 16 over 9. Okay, what I did was I just rainbow the minus h. So now I can differentiate this easily. So differentiate this, my h is constant. So bring down the 2, so it's minus 2ht. So this is minus 2ht. Differentiate this is 7h. This is a constant. When you differentiate, it disappears. So this is my new acceleration expression. Okay? And I'm going to use this. They're saying that this is at t is equals to 8. So I'm going to use this, sub in, and find my h. So now I'm going to sub in A2 is equals to negative 0.9 as well as t equals to 8. Common mistake is student never put in the minus. Okay, so it will be minus 0.9 equals to minus 2h8 plus 7h. So I have this side is minus, this side is minus 16h plus 7h and negative 0.9. So this one is minus 9h negative 0.9. Therefore, my h is equals to 0.1. Done. Okay? So this is how I solve the unknown. Can? All good? This is a little bit, this is kind of a tricky, it does come out this kind of question. In fact, this is a past year paper question, school past year paper question. So you need to know how to transit it to the new V. Okay, and then after that, need to take note, deceleration means acceleration is negative 0.9. Okay, they want my 8 so ugly. Wait. Okay. Now let's move on to the next question. Question number 5. Thank you. Okay, today kinematics is a tough topic lah. So I will most likely go beyond 1 hour. Okay, before I continue, help me to like and share to your friend, and let me take a sip of water. Thank you. And thanks for the nasi lemak. Okay, let's continue. So a particle moves in a straight line so that t seconds after passing a fixed point O, its velocity is blah blah blah. Find the value of t when acceleration. Okay, this one easy already. So first, let's find our acceleration. Just need to differentiate. So a is equals to dv dt. So my a, this one easy. Differentiate 5 disappear. Differentiate 4t is just 4. Bring down, so this is just minus 2t. Sub acceleration, this is a equals to 1. So I'm going to sub in a is equals to 1. So 1 equals to 4 minus 2t. So 2t is equals to 3. T is equals to 1.5 seconds. This one very straightforward. You just need to differentiate the velocity to get the acceleration. Sub in a equals to 1 and find the corresponding t. Nothing too complex about this part. Next, they say find the value of t when the particle is instantaneous at rest. So this simply means it's v equals to 0. Remember? By now you should know. Next is, let's do our v equals to 0. So my v is this one. So it is minus t squared plus 4t plus 5 equals to 0. And always make sure that it is positive. So what I'm going to do is, since it's an equation, I'm going to multiply by negative 1 throughout. So now I have t squared minus 4t minus 5 equals to 0. Factorize this. Factorize this. So you will have t minus 5 and t plus 1 equals to 0. So we have t equals to 5 or t equals to -1. Again, reject the negative. So this is my t. Okay, so now next. So this is similar to just now we learned the question whereby it's first 4 seconds, right? So this is same thing. And you can see that the v equals to 0 is t equals to 5. Okay, so it means that it changed direction before this 6. So you must draw your diagram. Later I'm going to do a additional question. Okay, they like to ask the question like find the distance at the 4th second. Okay, I will cover that after I settle these 6 seconds. Okay, so let me see. Let me see, the other one is important. Okay, so let's do our s. So my s, I need to integrate my velocity. Integrate v with respect to t. So s equals to integrate my 5 plus 4t minus t squared with respect to t. Integrate 5 is 5t. 4 put outside here. Integrate t is t squared over 2 minus t cubed over 3. Then don't forget your plus c. So in this case, my s is equals to 5t plus 2t squared minus 1/3 t cubed plus c. So I need to sub in a set of s and t in order to find my c, correct? So in this question, let's see. They never mention anything about the s and the t. So it means that by default, so in this case, by default, okay, they never mention anything special. So it means that s equals to 0 at t equals to 0. So with this, I'm going to sub this in. So I will sub in t equals to 0 and s equals to 0. So in this case, 0 equals to 5, 0 plus 2, 0 square plus minus 1/3 minus 1/3 0 square plus c. Just nice, it is 0, 0, 0. So my c is equals to 0. But not all the time it is this case. So c is equals to 0. So therefore, now I know that my displacement is s is equals to 5t plus 2t squared minus 1/3 t cubed plus 0, which I don't have to write it. Okay, so now next. I know that my it turns at t equals to 5. So I need to know where is my particle when t is equals to 5. So let's sub in t equals to 5. Okay, yep, into s. Into s. So my s will be equals to 5, refer to the s here, 5 plus 2, 5 square minus 1/3 5 cubed. 25 plus 50 minus 1/3 125. I get 33 1/3. So that means that when t equals to 5, my object is 33 1/3 meter away from the O. Next, because I want first 6 seconds, so I need to find where is my particle when t equals to 6. So I'm going to sub in t equals to 6 into my s. So this one I don't need to show you the working. After you sub in, you get 30 meter. 30 meter. So let's draw the diagram, which I tell you is very important to always draw the diagram. So this is my starting point. When t equals to 0, s is equals to 0. So that means it starts from here. Yeah, it starts from here. So t5 means that this one, when t5, t equals to 5, s is equals to 33 1/3. And when 6, it is 30, that means it come back here. So when t equals to 6, my s is equals to 30. Okay? So, by looking at the diagram, you will know that the distance traveled is equals to See, from 0 to 5, it travel 33 1/3. From 5 to 6, it actually only travel 33 1/3 minus 30, which is 3 1/3 only. So it will be 33 1/3 plus 33 1/3 minus 30. Therefore, it is 36 2/3 meter. Okay, distance travel is 33 1/3. This is the first 5 seconds. This is the 5th to 6th second. And then total distance travel for the first 6 seconds will be this answer. Understand? Okay, so now, just now I mentioned I want to do the extra question, which is, let me see where I should do it. Okay, I'm going to use red color. Okay, let me do it here. My IV, because just now we did part 3, this is the extra bonus question. I want to find the distance travel at the 4th second. 4th second. This is different from first 4 seconds. This is at the 4th second. So you must know that when they say 4th second, they want to know t equals to 3 to t equals to 4. Understand? So some students ask me, Sure, why is it not 4 and 5? Why is it 3 and 4? So very easy. I ask you this question. Find the distance travel for the first second. If I say first second, you will know that you will travel from 0 to 1. That is the first second I'm talking about, right? So it's the same concept. 4th second means it's 3 to 4. Understand? So in this situation, I will sub in t equals to 3 into my s to find out where is my particle. So my s will be 24. And at the same time, I also need to sub t equals to 4 into my s. So sub in t equals to 4 into your s. And your s will be 32 over 3 meter. Okay, So in this situation, look at the diagram. T equals to 3 is 24. 5 is here, right? So that means 24 is around here. So when t equals to 3, s is 24. When t equals to 4, my s is 30 2/3. So the distance traveled at the 4th second is, it was 24 from the O, and then after the 1 second, it becomes 30 2/3 away from the O. So what is the distance travel? The distance travel is only 30 2/3 minus 24. Agree? So the distance travel, therefore, the distance travel for the 4th second, is equals to this one minus this one. 30 2/3 minus 24. And that will give you 6 2/3 meter. Understand? Because from T3 to T4, it only travel this mini distance over here. So I need to minus them in order to know how much the particle has traveled. So that this is a very tricky question. So by drawing the diagram, you can visualize better. Understand? Okay, so let me see the next question. Okay, let's do one last question. One last question. Question number 6. Since my team has already prepared the 6 questions, I'm going to do 6 questions. Okay, let's do it. A particle moving in a straight line passes a fixed point A with a velocity of -8. So this information actually tells me that when t equals to 0, v is equals to -8. This information is given to you because later we are going to integrate. And when we integrate, we have a plus c. So this set of information is to find out the c. Okay, the acceleration after passing A is given by much. I think this one doesn't have this a. I don't need this one. Much. This one cancel the small a in front of the a. Okay, so acceleration after passing a is given by this expression over here. Thank you, Priscilla. Okay, where k is a constant, the particle first comes to rest at t equals to 1 and reaches a maximum speed. Okay, see here. Maximum speed is the same thing as maximum velocity. So this morning I was telling my students, so every time when you see, when they ask for maximum velocity or minimum velocity, you need to know that it is actually just a equals to 0. You need to know this concept. When you see at rest, v equals to 0. When you see maximum or minimum velocity, a equals to 0. Understand? Okay, remember this. So they tell me that it reached maximum speed at big T second. So this is trying to tell me that a is equals to 0 at t equals to t. Okay, this is what it's trying to tell me. For now, I don't know how I'm going to use it, but later we will use it. I believe so. So now they tell me that the particle does not come to rest between this time. So this is just trying to tell you that there's only one turning point, which is t equals to 1. Okay. So now you need to find the value of k. So my acceleration is this. A is equals to, hi James. A is equals to 10 minus kt. I need to find my v. I need to integrate my a. So v is equals to integrate a with respect to t. So that means v is equals to integrate 10 minus kt with respect to t. So my v is equals to 10t minus k t squared over 2 plus c. Plus c. So my v actually it is 10t minus k over 2 t squared plus c. So how to find the c? This is the set of values that we're going to use. So sub in t equals to 0 and v equals to negative 8. Minus 8 equals to 10, 0 minus k over 2, 0 squared plus c. So in this case, my c is negative 8. So with this, I know that my v is equals to 10t minus k over 2t squared minus 8. So this is your v expression, complete with the c that is found. Next is, to solve the k, I need to sub in v here, see here, this one. This tells me that v equals to 0 at t equals to 1. So with this, I can find my k. So I just sub in t1 and v0. 0 equals to 10, 1 minus k over 2, 1 square minus 8. We get 0 equals to 10 minus k over 2 minus 8. K over 2 equals to 2. So therefore, k equals to 4. Solve. Done. Okay? So you need to be very careful what you're subbing in. So you see over here, I make use of the T0 V minus 8. And I also make use of the V0 T1 in order to solve my K. Okay? Okay, next. Find the total distance traveled by the particle when T is equals to big T. So let's find my, what is this big T first? So remember over here, my A is 0 at T is equals to T. So my A is over here, and I already solved my K. So therefore, my A is equals to 10 minus 4T. You understand? So all I need to do is sub T is equals to, sub A equals to 0. So 0 equals to 10 minus 4T. 4T equals to 10. T is equals to 2.5 seconds. This tells me that my big T is 2.5 seconds. Understand? Okay, so now I need to find my s. Integrate. So I need to integrate my velocity. Where's my velocity? My velocity is here. Don't forget to sub in your k. So 4 divided by 2, it is 2. So in this case, I'm going to integrate 10t minus 2t squared minus 8 with respect to t. So it will be 10 t squared over 2, t cubed over 3 minus 8t plus c. So my s will be 5t squared minus 2/3 t cubed minus 8t plus c. So this question did not mention anything about t0 s is equals to what. So by default, we will sub t equals to 0 and s equals to 0. Just nice, this is c equals to 0. So therefore, my s will become 5t squared minus 2/3 t cubed minus 8t. Okay, they asked to find the total distance traveled when t is equals to 2.5 seconds. And I need to know whether it involves my turning point, correct? And remember, v is equals to 0 at t equals to 1. This is my turning point. So let's draw the diagram. Let's draw the diagram. So first, t0, s is 0. So I know it starts from the O. Next is, I want to find t equals to 1, where your particle turn. So over here, okay, I'm going to do the working here. Sub, sub t equals to 1 into the s. So my s will be negative 3 2/3. Again, don't panic. I hope you all don't panic already when you see minus. It simply means that my particle is behind here when it turns. So that means it's like that. So t equals to 1, s is equals to minus 3 2/3. Then after that it turns, right? It turns. Okay, 2.5, where is it? I don't know where is it until I find out. So I need to sub t equals to 2.5. And I will get my s is equals to 5/6 meter. It means that positive Positive means it's in front of the O, and it's only a little bit in front of the O. So I'm going to put here, this is t equals to 2.5. My s is equals to 5/6. So now let's see what is the distance traveled. Therefore, the distance traveled. Now let's take a look at the diagram. It was here. Okay, your task is to find out how much your particle has moved in order to reach this position over here. It was here. First 1 second, it traveled Gostan behind negative 3 2/3. So from here to here, it traveled 3 2/3. In order to come back to the O, you need to travel another 3 2/3. Agree? So this is 3 2/3. Here is 3 2/3. And from the O, go to the 5/6, you need to travel another 5/6. So the total distance traveled is actually 3 2/3 plus 3 2/3 plus 5/6. And therefore, it total traveled 8/1/6 meter. And that is the answer for this question. Okay, so by drawing diagram, you can see the distance traveled easily. So this question is not an easy one, but by drawing all the diagram, you will be able to solve how they ask. Okay, so we are done with the last question. Okay, I hope by now you'll be able to solve and do kinematics.